Welcome to our channel. Our today topic is to carry out static analysis of a flange assembly, of this flange assembly. In this assembly, both flanges are connected with each other using nut and bolt connections. And please note that these nut and bolt has been added using Solidworks toolbox. You will learn to convert these nut and bolt into nut and bolt connections in simulation studies, and you will also learn how we can create or generate a high quality curvature based mesh. Please note that this assembly is fixed at one end. At this end, and the load of 8000 Newton is applied on this face in y directions. You will also learn how to define contact using global interaction mechanisms in SolidWorks simulation modules. So let's start our simulation study now. So click on simulation tab and make a new study. Give it a specific name, that is Flange Assembly Simulations. Ensure that static study is selected. And another thing, please make ensure that check this box convert toolbox fasteners to bolt connectors. Just ensure that this box is checked. Using this option, these fasteners will be converted into bolt converters or bolt connectors. Okay. Wait for a while. So here is a message that 6 simulation bolt connectors were successfully created. Okay. So now these are not only fasteners, these blues are also bolt connectors. Our next phase or step is to assign materials to this flange assembly or flange parts. So click on both flange part, then right click and go to apply edit material and assign AISI 304 to flange parts. Apply, close. So AISI 304 material has been assigned to both parts. And what is the material of bolts? So in order to check the material of bolt, you can see here is the R2 converted bolt toolbox fasteners. Expand it and right click, edit destinations. So in order to check the materials, you can see here is the connectors in the connections list. Expand it and here are the bolt connectors. Right click any connectors and go to edit definitions. So here is the bolt connectors details where it describes its bolt diameter, nut diameter and also the shank diameter. And also ensure that elasteel has been assigned from material library. You can see here Head diameter is 27 millimeter and nut diameter is also 27 millimeter and the shank dia is 16 millimeter and its load bearing capacity. Okay. So after that we will make the component connections. Here the connection between these both flanges and between these boards as well as flanges. So go to global interaction options, edit definitions, and from the interaction type select contact. Here is by default option is bonded has been selected. We will select the contact from the interaction type and leave other values default. Okay. So contact global interaction type is contact that has been defined now. So we have defined the global interactions as well as bolt connectors. Our next step is to apply the fixtures. Right click on fixtures, select fixed geometry and select this face. Apply. So we applied a 6 degree of random fixtures on this face. Now assign a load of 8000 Newton on this face in these directions. Go to loads, right click and select the force. Select this face. You can see here load is normal to this face. From here select this option, selected directions. And select this top plane. You can see we select these options and in the reverse it's the directions and assign the value of 8000 Newton. So load has been applied in y directions. And now it's time to create a curvature base mesh. Using Solidworks meshing options, go to mesh, create mesh, and from advanced options, from mesh parameters, select curvature based mesh and leave the mesh element size default. Okay. Wait until mesh generated. So mesh has been created now. So it's time to run our study. So run this study and wait until our solution converge. You can see more details or convergence plot. So please subscribe our channel and give your comments and ask your questions in comments. Also share this video. Your suggestions are valuable for us. We also give CAD and simulations services. So please contact us. So our simulation study has been completed. From results tab, double click on stresses and see the von Mises stresses values. So von Mises stresses value is 107 megapascal. That is less than the material yield strength, that is 206 megapascal. So if we check the factor of safety, you can see the factor of safety is 1.9. That means our design is safe. So in order to evaluate the displacement, click on the displacement. So maximum deformation is 0.1126 millimeter. If you want to animate this, just make a larger scale and animate. And if you want to analyze the stresses, axial stresses on or shear stresses on these boards, and also you want to evaluate the movements on these boards, right click on results and select the here is the option list connector force and select the connector force from options. You can see the shear force on each bolt as well as axial force and as well as bending moment on each connector or bolt connector. So this is almost same for all these six connectors. You can see their values. So in this way we learn how we can define bolt connectors using SolidWorks toolbox fasteners. Also we created the curvature based mesh and also we learned how we can examine shear forces, axial forces as well as bending moments of bolt connectors. Please make a practice of this lesson. Thank you for watching. Subscribe and share now. Okay, take care.